Test the conjecture number 1 asks to evaluate the expression 7.3 times 10 to the 5th minus 4.9 times 10 to the 5th. According to our conjecture, we can add numbers in scientific notation when the values have the same magnitude. So first, we need to check and see if we have the same magnitude. To determine if we have the same magnitude, we look at our power of 10 and see if it's the same. In this case, I have 10 to the 5 and 10 to the 5, which means we have the same magnitude. If our numbers are the same magnitude, that just means that we can subtract our multipliers. So let's look at our subtraction. I have 7.3 minus 4.9. I can carry over to my 3. And I'm left with 2.4. When we subtract, we keep the same magnitude, so my magnitude is still going to be 10 to the 5th power. And I have my answer. If I wanted to check my work and make sure that my answer is correct, I can quickly expand my numbers. So 7.3 times 10 to the 5th is going to be 730,000 minus 490,000. I know that's equal to 240,000. And moving that back into scientific notation, I would get 2.4 times 10 to the 5th. So our answer checks out, that even expanding it out, we would still get the same value of 2.4 times 10 to the 5th. Now let's go and look at test the conjecture number 2. Conjecture number 2 says, Nicole is inventorying 2 different warehouses. In the first warehouse, she determines that there are 4.6 times 10 to the 3rd power boxes. In the second warehouse, she determines that there are 5 times 10 to the 4th boxes. What is the combined number of boxes in both warehouses? First, let's look and see what information we can take from our problem. I know that in our first warehouse, we have 4.6 times 10 to the 3rd boxes. And in my second warehouse, we have 5 times 10 to the 4th boxes. The question is asking us to find the combined number of boxes in both warehouses, which means we need to add them to find the total combined number of boxes. So if I have 4.6 times 10 to the 3rd boxes and 5 times 10 to the 4th boxes, and we need to add those together, what can we do? Our conjecture says that we need to have the same magnitude in order to add values in scientific notation. So our first step is going to be to determine the magnitude. And our first number, I can see that our magnitude is 10 to the 3rd. And my second number, I can see that my magnitude is 10 to the 4th. So, do we have the same magnitude? No, we have different magnitudes. So what can we do in order to add these numbers? I don't want to have to convert to standard form to add these numbers together. So how can I change the magnitude of one of my values so that we can add these numbers together? 10 to the 4th is the bigger of my 2 magnitudes. So let's see if we can rewrite that number so that it has the same magnitude as 4.6 times 10 to the 3rd. In our power rules that we learned last week, remember that multiplying values with the same base is the same as adding the exponents together. So let's see if I can find values of my exponents that when I multiply a base 10 together will add up to 4. I know that I want to have the same magnitude as my first number. So I want to have a value of 10 to the third. I know that if we need to add our exponents together, 3 plus 1 will equal 10 to the fourth. That means that I can rewrite my expression for my second number as 5 times 10 times 10 to the third power. I can simplify this out, so now I have 50 times 10 to the third power as my second value. Now that I have 10 to the third, I have the same magnitude as my original number. Now that I have the same magnitude, what can we do? I can add my multipliers together. I now have 4.6 times 10 to the third plus 50 times 10 to the third. Now, again, that we have the same magnitude, I can just add my multipliers together. So I have 54.6 and keep my same magnitude times 10 to the third power. Let's go back and look at the steps that we just did. Once we determined my magnitude, we needed to change and rewrite value so that both numbers have the same magnitude. Now that we have the same magnitude, we can go ahead and add our multipliers. Let's look at our answer. If I have 54.6, what is our rule for writing things in scientific notation? Our multiplier A needs to be between 1 and 10. So what can I do in order to get this into proper scientific notation? I have 54.6 times 10 to the third power. I need to move my decimal place over one more time, which means I need to multiply by 10 one more time. If I have 5.46 times 10 times 10 to the third, I can simplify these 10 times 10 to the third by adding my exponents together. So I get 5.46 times 10 to the fourth. Now that I'm in proper standard or scientific notation, I can write out my sentence. Remember that our last step is to convert into proper scientific notation, meaning our value of A is between 1 and 10. Now that you guys have the steps in adding or subtracting numbers in scientific notation, go ahead and complete your independent practice and your exit ticket on your own.